Tonight's video is section 4.4, Fundamental Theorem of Calculus. Your homework out of 4.4 is 1 through 4 all, 5 through 15 odd, 18, 19, and 22 through 26 all. Fundamental Theorem of Calculus is if f is continuous in the closed interval from a to b, and capital F is the antiderivative of f on the closed interval from a to b, then the definite integral from b to a of f of x dx equals capital F b minus capital F of a. What this is this is the calculus way to find the area under the curve. In other words, this is the way to take the antiderivative or the integration. Now we do not have to sketch or do the area. We did not know how to do this before, so we had to sketch and find the area underneath the curve, which is what this is. Now we no longer have to. So let's go ahead and let's do a problem. Here's an example. Here is a definite integral. We're going to integrate from 2 to 7 of 3 dx. And so when I go ahead and I do the integration, that's 3x, and I'm going to do it from 2 to 7. So remember that this has got to be the larger number and this is the smaller number, those bounds. And so based on this part right here, now what you do is you take this function, you substitute in the larger value, minus, then you substitute in the larger value to whatever this function is. So you want to be very careful, have brackets and parentheses everywhere. This is a pretty straightforward problem, 21 minus 6, which equals 15. Let me prove to you this is the same what you were doing with the area underneath the curve. So here is the conceptual understanding. What we did before is we said that is the line y equals 3 with the two vertical lines at 7 and at 2. That formed a rectangle. And so the area of a rectangle is base times height, which is 3 times 5, which is 15. So they are one in the same. But now I don't have to draw. Next problem. Let's go ahead and take a definite integral from 2 to 5 of negative 3x plus 4 dx. Well, because I already know there's going to be lots of negatives, I'm going to go ahead and switch those two around. I can. I'm going to put the positive 4 first and the negative 3x second. Now I'm going to go ahead and take the antiderivative. So 4, antiderivative is 4x minus 3x. I'm going to increase that power and divide by that power from 2 to 5. Here's where I do my substitution. I must take this whole thing, substitute in 5, minus take this whole function, substitute in 2. Please be very careful with all your parentheses. I'm not going to read this to you. You can watch this. Make sure you know how I got through everything. That is the area under the curve. Let's try another one. Here's an example. Again, please notice my bounds. This is larger number, this is smaller number. That's an agreement. So I have x minus 1 over x squared dx. First thing I'm going to do is I'm going to rewrite this before I take the antiderivative. So this is the definite integral from negative 2 to negative 1, x minus x to the negative 2 dx. Let's go ahead and take the antiderivative, or integrate this. So this is x squared divided by 2 minus x, remember increase that by 1, negative 1, divide by that new exponent. And that's from negative 2 to negative 1. Before I go ahead and I substitute in the negative 1 and the negative 2, I'm going to go ahead and simplify this. So it's 1/2 x squared, double negatives, plus 1 over x. From negative 2 to negative 1. Now I'm ready to substitute in the negative 1 first, minus substitute in the negative 2 into everything here, which is exactly what I did here. Trying to clear up. Hopefully you can see that clear enough. I had made a mistake, and it was 3/2. It's -4/2, that's a -2. So make sure you can follow that. Please notice I'm keeping that very straight with the minus in between. One more problem. This is an absolute value problem. So we're going to use a definition back in Algebra 1. Definition of the absolute value of x equals x for x is greater than or equal to 0, or the absolute value of x is the opposite of x if x is less than 0. So I have this definite integral from 0 to 3 of the absolute value of 2x minus 3 dx. And I will show you the conceptual understanding in a moment. I will go ahead and I will graph that, and we'll do the area underneath the curve. But right now I want to do it the calculus way. First thing I need to do is I need to use that definition. So I'm going to do what's inside, 2x minus 3 greater than or equal to 0, and x is greater than or equal to 3/2. So then this is the opposite of what's inside. So the opposite of what's inside, well, the signs all change. That's 3 minus 2x, and that's x less than 3/2. So now I'm going to have to separate that into two problems because this is in between 0 and 3. So here's what I have to do. X less than 3/2, I have to use that function. So 3 minus 2x from 0 to 3/2, because I'm only supposed to go from 0 to 3. Plus, I do the definite integral from 3/2 to 3. I use this function. So now I have two sets of integration to do. So 3x minus 2x squared all over 2 from 0 to 3/2 plus 2x squared over 2 minus 3x from 3/2 to 3. Problem get a little long, but it's not too bad. There's some zeros in here. So I have to put in 3/2 first, minus, now put in the 0. There's my plus. Now I have to put 3 into here, minus, now I put 3/2 into here. I continue to simplify. That's 9/2. That's 9/4 minus 0, plus, keep it really straight, 9 minus 9 minus, that's 9/4 minus 9/2. So I went ahead and changed that, multiplied that by 2 over 2, so that's 18 minus 9/4, plus, I put that there to make sure I could still see that negative. Multiply this by 2 over 2, so that's 9 minus 18/4. So that is 9/4 minus my negative 9 over 4, which is 9/4 plus 9/4, which is 18/4, which is simplified to 9/2. I'm going to go ahead and take this same problem and show you how you do this visually. Conceptual. You have the absolute value of 2x minus 3 from 0 to 3. So first thing I did is I graphed the line 2x minus 3. What's inside of here? I graphed it from 0 to 3. So you know that negative 3 is the y-intercept. The slope is rise 2, run 1. 2, 1, 2, 1, 2, 1. I drew a line. But I had told you before when we were drawing these out that it says absolute value, that any area underneath the curve, you count that as positive. So this is positive and this is positive. So what the absolute value is really doing is it's taking this piece and it has flipped it up on top. That's what that does. With the absolute value, when you take what's inside and graph it, then all the pieces that are below, you just flip up on top. And so I went to 3, I went to 3. It's at 1.5, it's at 1.5. Now let me show you. The area from 0 to 3 is 2 of these triangles. They're each the same. So 2 times what? 1/2 base is 1.5, which is 3/2, times a height of 3. So that would be 9 over 4 times 2 of them, that's 18 over 4, that's 9/2. So I can see it like this, and then I have to know that this is positive, and with the absolute value, this is also positive. It's only when there's an absolute value. If there's no absolute value, that's negative and that's positive. Thank you.